Hello students, welcome. So today we are going to start a new unit 8, the D block elements. So basically it is D and F block elements, but the majority of the portion is related to D block elements, and we have some basic information regarding to F block elements. Now generally F block elements are majority of them are radioactive, so they are hard to study with. That's why we do not have much details regarding to them. So whatever the details we have, we are going to discuss in this unit, and we are going to discuss about D block elements in detail, and certain portion of this unit are related to our other unit, coordinate complex compounds, because many complex compounds are made up of D block elements. So let's check objective first quickly. So first of all, learn the position of D and F block elements in the periodic table. Know the electronic configurations of the transition D block and the inner transition F block elements. Now why they are called transition? Because in their basic structure, electrons will transfer from one orbital to other orbital, and this change of orbital for the electron is called transition. So that's why they are referred as transition and inner transition elements. Appreciate the relative stability of various oxidation states in terms of electrode potential values. Now what is electrode potential values? So as we discussed in electrochemistry, electrode potential can be referred as tendency to reduce itself, and during this either it needs electricity as an energy source or it will produce the electricity, and this value is known as electrode potential. Describe the preparation, properties, structures and uses for some important compounds such as K2Cr2O7 and KMnO4. Now both of these compounds are coordinate complex compounds, and in coordinate complex compound you have ionic bonds and coordinate covalent bonds. We will discuss about it in details. Understand the general characteristics of D and F block elements and the general horizontal and group trends in them. Describe the properties of the F block elements and give a comparative account of the lanthanoids and actinoids with respect to their electronic configurations, oxidation state and chemical behavior. Now lanthanoid and actinoids are two different series of F block elements. You will notice in F block we have two different periods, and the first period is known as lanthanoid, named on the first element of that series, lanthanium, and similarly second series is known as actinides, named on the first element of the series, actinium. So now let's start with our introduction portion. So as we know, F block elements in periodic table are start from the group 3 and ends with group 12. First to group 1 and 2 belongs to S block elements, and 13 to 18 belongs to P block elements, and these 10 blocks or 10 groups belongs to D block 3 to 12. And as we move, then d orbitals will progressively filled in each of the 4 long periods. The F block consists of elements in which 4f and 5f orbitals are progressively filled, and they are placed in the separate panel at the bottom of the periodic table. The name transition metal and inner transition metal are often used to refer the elements of D and F block elements respectively, as we observed in objectives. So the main 4 series of the transition metals, 3D scandium to zinc, 4D yttrium to cadmium, 5D lanthanum and hafnium to mercury, and 6D series which has actinium and rutherfordium to copernicium. So notice here in the 5D and 6D series, first element are mentioned lanthanum and actinium. So and these same elements are used for the nomenclature of two different series of F block elements. So that means these two elements actually do not belong to F block element, because for F block element F block series you have to be partially filled at F orbitals. In these two cases, that means lanthanum and actinium, their F blocks are completely empty, or F orbitals are completely empty. That's why they are not considered as F block elements. The two series of the inner transition metals 4f and 5f are known as lanthanoids and actinoids respectively. Now reason for the name of transition metal. So this name is derived from the fact that their chemical properties were transitional between those of S and P elements. Now according to IUPAC, transition metals are defined as metals which have incomplete d subshells either in natural atom or in their ions. That means if these elements do not have partially filled d orbital in their atomic state, but if it has in its one of the ionic state, you will notice in this case some metals can show multiple different type of oxidation states. So if any one of that oxidation state contains partially filled d orbital, then they are considered as transition metal. That means D0 and D10 are not allowed in transition element series. If configuration is D0 or D10, then they are not considered as D block elements. But if it is D1 to D9, if number of electrons in d orbital is from 1 to 9, then they are transition element in their atomic state or one of the ionic state. So that means if you check the electronic configuration of zinc, cadmium and mercury of the group 12, you will notice they have fully filled d orbitals. So according to this definition, we should not consider them in d block element. But their chemical properties and some other properties are similar to d block elements, and that's why we will study them together. Now the presence of partially filled d and f orbitals in their atoms makes transition element different from the others, and that's why they are studied separately. However, the usual theory of the valence as applicable to the non-transition element can be applied successfully to the transition element as well. So we can check their hybridizations and other data as we already learned in previous units and standards. So it will be same. You can apply same rule for this type of element with some exceptions. Various precious metals such as silver, gold and platinum and industrially important metals like iron, copper and titanium belongs to transition metal series. In this unit, we shall first deal with the electronic configuration, occurrence and general characteristics of transition element with special emphasis on trends in the property of first row 3D transition metals along with the preparation and the properties of some important compound. This will be followed by consideration of certain general aspects such as electronic configurations, oxidation state and chemical reactivity of the inner transition metals. That means just like previous series, that means the previous blocks, S blocks or P blocks, we are going to follow the same trend. First we will discuss about individual members of the groups, then we are going to discuss their some elemental and electrical configurations or chemical properties, physical properties. Then we will discuss about some of the important compounds of respective element. We did follow this trend in P block elements as well. So first we are going to discuss about transition elements, that means D block elements, and mainly we are going to discuss in detail about first series 3D. So first point is position in periodic table, and we already know where the D block elements are present. So large middle section of the periodic table is occupied by D block elements. In other series, that means in S block we have only 2 groups, whereas in P blocks we have 6, but in D we have total 10. So we can say that majority or a large number of groups belongs to D block, and it is present between S and P blocks. The d orbitals of penultimate energy level of atoms receives electron, giving rise to 4 rows of the transition metal, that is 3D, 4D, 5D and 6D. All of these series of transition elements are shown in table 8.1. So here are these series. So first series, that means 3D, all of these series contains 10 elements each. And actually last element of each series contains fully filled d orbital. That means as we can see in this case we have d last element of series, which is zinc. It contains d10 electronic configuration. As you can see in this table, first thing Z represents atomic number, then 4s, it represents electron present in 4s, and 3d, that means electrons present in 3d orbitals. So if 3d orbitals are partially filled, then these elements are considered as transition elements, or it belongs to 3D series or D blocks. But in this case, If you notice, last two elements, copper and zinc, both of them contains 10 electrons in their d orbital. So they are fully filled. That means we should not consider them in d block elements. But copper has partially filled d orbital in one of its oxidation state. It has two different oxidation state, +1 and +2. In +2 oxidation state, we have d9 electronic configuration for copper. It represents its partially filled or incompletely filled d orbital. That's why it is the member of d block. But in case of zinc, we have only one oxidation state and it is Zn+2. So that means in case of zinc, we do not have partially or incompletely filled d orbital in its atomic state or its ionic state. That's why it is not considered as per definition as transition element, but still we are going to study these elements with respective other members. So this is second series, Y to CD, La to Hg and Ac to Cn. So these are the elements which we are going to study, and we are going to study in detail these first 10 elements in next lecture. Thank you.